Hello and good afternoon everyone, guys. I welcome you all once again to this wonderful channel by Unacademy NEET English. I believe that you all are doing great and have a good time. Well, my name is Kar Khurshid Alam and you can also call me KK sir. But before we move ahead, I want quick confirmation that if you can see me clearly and hear me clearly, let me know in the chats quickly. Let me know in the chats. If you can see me clearly and hear me clearly, let me know in the chats. Okay. I believe that we are live now and super excited for today's session. Well, I have already promised you that we will deal with top 20 concepts of organic chemistry. We are already done with most of these concepts, and in today's session, we will complete these top 20 concepts. Well, my dear students, I will once again ensure you that your NEET paper will be around these concepts only. So, I would want you all guys to be with me till end of this session. And I would want also to mark the attendance by smashing the like button. And do share this stream with your friends as well. So without wasting much more time, let's get going. But before that, let me know in the chats, how is the Josh, guys? How is the Josh? Are you ready for today's session? Yes or no? You can show some green hearts there. You can show some fire emojis as well. Come on. Come on. Thank you, Umar. Thank you, everyone. Thank you, everyone. Thank you, everyone. Okay, you can. Okay. So without wasting time, let's start today's concept. And today's concept is basic strength of amines. First of all, we will take basic strength of aliphatic amines. First of all, we will talk about basic strength related to aliphatic amines. So we will discuss, first of all, basic character of aliphatic amines. But let me tell you that this, basicity of aliphatic amines, basicity of aliphatic amines is medium dependent. It is medium dependent. So that's why, first of all, we will be discussing basicity of amine in gaseous phase. In gaseous phase or aprotic solvent. That means the solvent which cannot donate H positive. So aprotic solvent, or we can simply say non-aqueous media. Non-aqueous media. Have a look. In this phase or in this media, remember, in this phase or in this medium, we will simply say that basicity of amines is directly proportional to electron donating nature, or it's directly proportional to electron donating group attached to the nitrogen, of an amine. So have a look. So here basicity depends on the electron donating or electron withdrawing groups attached to, amines. But if electron donating group is directly attached to amine, at that time basicity of amine will be increased. But if electron withdrawing group is attached to amines directly, then its basic character will be decreased. That's why among primary amine, secondary amine, and tertiary amine, basicity order will be simply like this. It will be tertiary amine, which is more basic. After that, it is simply secondary amine, and after that, it is a primary amine. Why? Why is it so? Why tertiary, then secondary, then primary amine? Because here medium is not that medium which can solvate these amines, or there are no H positive present in this medium. Hence, we will simply say that more the electron donating groups attached to nitrogen, these electron donating groups will increase electron density of nitrogen, and here nitrogen will simply donate its electron more easily as compared to this, because this is having 2 electron donating groups, it's having 1 electron donating group. So this formula says that basicity of amine is directly proportional to electron donating groups attached to amine. So here electron donating groups are 3, here it's 2, here it's 1, so it's 3, 2 and 1. Now let me know in the chats quickly, am I clear? Let me know in the chats quickly, am I clear? Let me know in the chats quickly, am I clear? Come on, let me know in the chats. Let me know in the chats quickly. Okay, thank you, Meena, thank you, Sang. Okay, thank you, Nityasri. Thank you, Shafkat. Okay, thank you, Shamala. Thank you, Kanmani. Thank you, Chrissy. Thank you, everyone. Thank you, everyone. After that, so this is if, this order is only applicable if, bases belong or bases are present in gaseous phase. That means this is the order of gaseous phase. But if we talk about basicity in aqueous medium, or protic solvents, then what will happen over here? Have a look. Then we know in protic solvent or in aqueous media, our base, say for example primary amine, will result in the formation of its conjugate acid, by accepting the proton from this water or from solvent. So it will result in the formation of a conjugate acid like this. So this is the conjugate acid, and in this reaction this acts as a base. So primary amine in this reaction acts as a base, and it will result in the formation of a conjugate acid. Similarly, secondary amine will accept a proton from this medium and will result in the formation of a conjugate acid like this. So this is the conjugate acid of secondary amine. So this is secondary amine. Once again, it acts as a base. Similarly, tertiary amine in this medium can act as a base by accepting this proton, say from water. So this is water, and it will accept a proton from water, and it will also result in the formation of a conjugate acid. Now, remember, for this type of medium, basicity is basically dependent on, basicity is directly proportional to stability of its conjugate acid. It's directly proportional to stability of its conjugate acid. That means if this is the conjugate acid, this is the conjugate acid, this is the conjugate acid. Say for example, if this conjugate acid is more stable among these, that means this base is stronger base among these. Similarly, if this conjugate acid is more stable than these two, then this base is more stronger than these two bases. So basicity depends on stability of its conjugate acid in this medium. Now, have a look. Remember, this stability of conjugate acid actually depends on two factors over here. One, we can say simply that it is dependent on plus I effect of alkyl group, plus I effect of R, amines alkyl group, and number second, extent of hydrogen bonding, extent of H bonding, or you can say solvation. So these are the two factors on which stability of conjugate acid depends. So if basicity depends on stability and stability of conjugate acid depends on these two factors, that means basicity actually depends on these two factors. So have a look. Is this, I mean to say, visible to you? Is everything clear to you? Is everything clear to you? Let me know in the chats first. Is everything clear to you? Is everything clear to you? Let me know in the chats. Let me know in the chats quickly. Okay, crystal clear. Okay. Then it's okay. So now we will discuss first of all plus I effect of R. Have a look. So we have to now discuss stability of conjugate acid on the basis of plus I. So I will write down over here stability of conjugate acids on the basis of plus I of R. Have a look. This is very important. So remember this. Now we know conjugate acid of primary amine is this one. Conjugate acid of primary amine is this. Then we have conjugate acid of secondary amine like this. Then we have conjugate acid of 3-degree amine like this. Have a look. All these conjugate acids are positively charged. When they are positively charged, that means if alkyl group is attached to this positively charged, nitrogen, it will donate its electron, or nitrogen positive will accept its electrons or attracts its electron towards itself. So its positive charge will be little bit decreased. Similarly, this R will give electron and it will decrease positive charge of nitrogen. But here positive charge of nitrogen will be decreased more as compared to this, because here only one electron donating alkyl group was present. Here two alkyl donating groups are present, and here 3 alkyl groups or electron donating plus I groups are present. Now, so can I say this, conjugate acid is having 3 alkyl groups. So 3 alkyl groups will give its electron more as compared to 2 alkyl groups as compared to 1 alkyl group. Hence, this will become, more stable because its positive charge will be decreased. So magnitude of positive charge over here on this nitrogen will be more, and magnitude of positive charge on this nitrogen will be less. So the stability order on the basis of plus I will be like this. So this is the stability order. So this will become the stability order among conjugate acids. But on the basis of plus I. So can I say on the basis of plus I, it is 1 degree, which is lesser than, less stable than 2 degree. 2 degree is less stable than 3 degree. So what will be the basicity order then? Basicity order on the basis of plus I will be 1 degree amine is weaker base than 2 degree amine. 2 degree amine is weaker base than 3 degree amine. Or we can simply say 3 degree amine is a stronger base than 2 degree amine than 1 degree amine. But on the basis of this order is on the basis of plus I of R. This is on the basis of plus I of R. Now, let me know in the chats, am I clear till now? Let me know in the chats, am I clear till now? Am I clear till now? Let me know in the chats quickly. Quickly, my dear students, let me know in the chats. Am I clear? Am I clear till now? Am I clear? Okay. Now after that, this was stability on the base of conjugate acid. This is stability of conjugate acid on the base of plus I. Now we will be discussing stability of conjugate acid on the base of extent of hydrogen bonding. So now next is stability of conjugate acid on the basis of H bonding, or you can say on the basis of solvation. So on the basis of H bonding, we will discuss stability of conjugate acid. Have a look. This is the conjugate acid of 1 degree amine. This is the conjugate acid of 2 degree amine. And this is the conjugate acid of 3 degree amine. Now, can I say, as these conjugate acids are present in a solvent, say for example water, then in water or in aqueous medium, negative part of water will form a hydrogen bond with this hydrogen. Similarly, oxygen can form a hydrogen bond with this oxygen. This I mean say hydrogen. Similarly, oxygen will form hydrogen bond with this I mean to say hydrogen. Here, two hydrogen bonds can be formed by a single molecule of I mean say this conjugate acid. Similarly, this conjugate acid can form one hydrogen bond with water molecule. So, what is hydrogen bond actually? Hydrogen bond is basically electrostatic force of attraction between this positively charged, slightly positive charged hydrogen and slight negative charge of this oxygen. So it is force of attraction basically. So more the number of hydrogen bonds, more will be the force of attraction. More the force of attraction, lesser will be energy. That means simply more the force of attraction, more will be the stability. Hence, we will simply say that this conjugate acid is more stable due to hydrogen bonding than this, and this is more stable due to hydrogen bonding than this. That means this is the what we call stability order. This is the stability order among conjugate acids. Now, if this is the stability order, then what will be the basicity order? Can I say then basicity order will be simply basicity order among amines, aliphatic amines will be simply 1 degree amine greater than 2 degree amine greater than 3 degree amine. Now have a look. This is 1 degree, 2 degree, 3 degree on the basis of, this is the basicity order on the basis of H bonding. But here, this was the basicity order on the basis of plus I. So this is 3, 2, 1. This is 1, 2, 3. So both these factors basically favor this 2 degree. This 2 degree. And there is doubt between 3 degree and 1 degree. So we will simply say that both these factors favor 2 degree, that means secondary amine. Hence, 2 degree amines, secondary amines are considered strongest bases among amines. So in aqueous medium, we will simply say that 2 degree amines are the strongest bases among 2 degree, 1 degree and 3 degree amines. But among 3 degree and 1 degree, we have still doubt. So that's why to clear that doubt, I will once again write down a conjugate acid of primary amine. and conjugate acid of tertiary amine now. Because there is no doubt in, I mean to say, 2-degree amine. That's why I will not write conjugate acid of 2-degree amine. There is doubt between 3-degree and 1-degree or 1-degree and 3-degree. That's why I will write down once again their conjugate acids. Now, have a look. Here, we are having two basically cases. Case 1 is if R is small. If R is small, that means if alkyl group is small. And we know smallest alkyl group is when R is equal to CH3. Listen carefully. If we want to, discuss their stability depends on two factors. Number one is plus I of R and number second is extent of hydrogen bonding. Now, tell me, if R is CH3, so can I say among alkyl groups, decreasing order of plus I is tertiary, secondary, primary and methyl. That means among alkyl groups, methyl is having least plus I order, or it's having, it is the group which shows least plus I. If it shows least plus I, its plus I can be neglected as compared to other alkyl groups. So, if R is small, that is this one, then we can neglect its plus I. If we neglect plus I, then another factor is there, and that factor is extent of hydrogen bonding. Now, as R is small, this is small, water will come to form a hydrogen bond, and there will be no steric repulsion, or steric repulsion will be very less compared to other alkyl groups. Hence, remember, we simply neglect plus I, but we cannot neglect hydrogen bonding, as hydrogen bonding takes place easily because R will not repel, or electron cloud of R will not repel electron cloud of water, as the value of R is very less. Now, R is very small. That's why at this time, stability of conjugate acids will be decided by H bonding only. Why only H bonding? Because we have neglected plus I. So now stability will be decided by H bonding only. Have a look. It can form 3 hydrogen bonds with 3 water molecules. It can form only 1 hydrogen bond with 1 water molecule. That means more hydrogen bonding takes place over here. So this is more stable because of more hydrogen bonding. So therefore, what will be the stability order? Stability order of conjugate acids. Stability order of conjugate acids will be 1 degree. Conjugate acid of, 1 degree amine will be more stable than conjugate acid of 3 degree amine because of more hydrogen bonding. So therefore, basicity order will be, among these two, basicity order will be simply, it will be 1 degree amine greater than 3 degree amine. But can we say then, overall basicity order will be, overall basicity order will be simply 2 degree, because 2 degree is the strongest base among amines. So 2 degree, after that it's 1 degree, after that it is 3 degree. So this is the order when R is CH3. So this is the case when R is CH3, you have to remember this order: 2 degree, 1 degree and 3 degree. But in aqueous solutions or protic solvents, let me know in the chats if I am clear till now. Let me know in the chats if I am clear till now. Thank you, Ajay. Thanks for replying. Thank you. God bless you. Yeah, it's crystal clear. Okay, thank you. Thank you, Meena. Thank you, Shafkat. Okay, Kashu, yes, sir. Okay, Nityasri, clear. That's great. That's great. Thank you, everyone. Thank you, everyone. So, with the help of trick, you can remember this order like this. Among 1 degree and 3 degree amines, among 1 degree and 3 degree amines, 1 degree amine is smaller because of only 1 alkyl group, and 3 degree amines is larger because of more alkyl groups. So remember, when value is small, you have to write down 1 degree and 3 degree. Among 1 degree and 3 degree, you have to write down smaller one first and after that larger one. 2 degree is say the strongest. After that, write 1 degree first, then 3 degree when R is small. But case number 2, case 2 is if R is large. It can have many values, but you have to remember only this value, that is if R is equal to ethyl. Now, as R is ethyl, so we cannot neglect its plus I power, because its plus I power is still greater than CH3. So we cannot neglect plus I. Now, another factor is what we call hydrogen bonding. Remember, if R is large, that means R in comparison to methyl is now bulky. Have a look. If this R value is bulky, that means it will simply, its electron clouds will repel the electron clouds of water molecule, which will come to form hydrogen bond. What does that mean? That means what we call water molecules will be, an electron cloud of water molecule will be repelled by electron cloud of alkyl groups. Hence, there will be lesser, say hydrogen bonding, or extent of hydrogen bonding will be very less. As extent of hydrogen bonding at this time, because of steric repulsion, will be very less. So we can neglect. So if R is large, we can neglect hydrogen bonding. We can neglect hydrogen bonding or H bonding, because H bonding or extent of H bonding at this time when R is large is very less due to steric repulsion. So at this time we can neglect H bonding. Hence, stability of conjugate acids will be decided by plus I of R only. Here it will be decided by plus I of R. Have a look. Here it's only 1 R. Here it is, say 1, 2 and 3 R groups are present. That means more the R groups, more will be, say donation of electron from these groups towards this positive charge species, and its magnitude of positive charge will be, say decreased. Hence it becomes more stable. So more alkyl groups simply increase the stability of tertiary as compared to what we call primary. So therefore we can simply say, therefore stability order among conjugate acids will be simply 3 degree greater than 1 degree. So our basicity order will be, dear students, that will be 3 degree amine greater than 1 degree amine. This was conjugate acid order. This is basicity order. So therefore I can simply say that overall basicity order among aliphatic amines will be 2 degree, 3 degree and 1 degree. But this order will be only and only if R is large, and that too what we call CH3, CH2, say ethyl. So this is the order if R is ethyl, and this is the order if R is methyl. This is the order if R is methyl. But this order or this order is basically applicable if basicity of aliphatic amines, if we discuss basicity of aliphatic amines, but that too in aqueous solution or polar protic solvents Now, let me know in the chats, am I clear till now? Is basicity of aliphatic amine clear to you? Is basicity of aliphatic amine clear to you? Let me know in the chats quickly. Is basicity of aliphatic amine clear to you? Okay, that's great. Thanks for replying. Now, after this, we will be having basicity of alkyl amines. What are alkyl amines? Remember, alkyl amine means alkyl amine basically are alkyl, they are aryl substituted aryl substituted, I mean say alkyl amines. Aryl substituted alkyl amines. For example, listen. This is what we call an simple example of R-alkyl amine. Why? Because R-alkyl amine was like this, CH3NH2. This is the alkyl amine. This is alkyl amine. If I replace one of the hydrogens by aryl group, so this becomes R-alkyl amine. And remember, R-alkyl amines are less basic than alkyl amines in general. R-alkyl amines are less basic than alkyl amines in general. Why? Because here, instead of hydrogen, we introduced electron withdrawing group. What will it do? It will simply withdraw electrons away from this nitrogen and it decreases the electron density of nitrogen. Hence, this is not now available for protonation in that way as this is available for protonation, because here only electron donating group is present. So we can simply say that if electron donating group is attached to nitrogen, it increases its electron density and hence this base becomes stronger base. That means basicity is directly proportional to electron donating group and basicity is inversely proportional to electron withdrawing group. Similarly, if we are having a base like this, CH2, CH2, CH2NH2. Have a look. This is number one. This is number one. Number second is this one. CH2, CH2, and then NH2. And third one is like this. This is CH2 and NH2. Now, all these groups are, these phenyl rings are electron withdrawing groups. But this electron withdrawing group is having more distance. I mean, say this is far away from this nitrogen. This is a little bit closer to nitrogen and this is very close to nitrogen among these three. So we know that when electron withdrawing groups are closer to nitrogen, their minus I effect will be more as compared to this, So more stronger electron withdrawing group, lesser, I mean say weaker will be the basic character. That means here basicity order will be simply, one will be stronger base as compared to 2 as compared to 3. So in general, we will simply say that basic character or basic strength is directly proportional to electron donating group and inversely proportional to electron withdrawing group. Now, this is more stronger electron withdrawal. Its effect will be more on this nitrogen because of lesser distance and its effect will be less because of more distance. So simply this will become more stronger base than this, So this was all about R-alkyl amines. Now, after that, we will be having another type of amine, that is aryl amine. That's why let's discuss basicity of aryl amines. I mean say those amines in which nitrogen is directly attached to, aromatic ring. Have a look. Say for example, you are having this one. This is known as aniline. And we know this aromatic amine and this aliphatic amine, among these two, this aliphatic amine is more basic. Why? Because its lone pair is not delocalized. This is localized lone pair. Of electron. This takes part in resonance. That means this is delocalized lone pair of electrons. And we know when it takes part in resonance, its electrons are not that much available for protonation. It does not take part in delocalization, so its electrons are more available for protonation. Hence, this is stronger base as compared to this. So this is point number one. Point number second is, if we are having an aniline, and after that, suppose we replace hydrogens present on this nitrogen. That means we will replace that hydrogen by alkyl group. And after that, we replace both these, I mean say hydrogens by alkyl group. So what will be the effect? What will be the effect of these substituents, if they are attached to nitrogen, what will happen? Have a look. Here, this CH3 will donate electron and it will increase electron density of this ring. Similarly, this will donate its electron and will increase electron density of the ring. Just a moment. Give me a second. Give me a second. Give me a second, my dear students. Now, so what will happen? This will also donate its electrons. Now, what will happen? What will happen now? Here we know when the substituents attached to nitrogen instead of hydrogen are electron donating, they will increase electron density of the nitrogen, and that nitrogen or that base becomes stronger base. So what will be the basicity order over here? Basicity order in this case will be simply 3 greater than 2 greater than 1. But if substituents are like this, if substituents are like these, we are having aniline, then we will replace this hydrogen by, say for example, another phenyl ring. What will happen over here? One hydrogen is replaced by phenyl ring. Now, I will replace another hydrogen by another phenyl ring. Now, what will happen over here? Basically, these phenyl rings will act as an electron withdrawing groups. It will act as electron withdrawing groups. That means this phenyl ring can now withdraw electron from this nitrogen. Similarly, this can withdraw from this can withdraw electrons from this nitrogen because of resonance. That means there are two, electron withdrawing groups. Here are 3 electron withdrawing groups. Here, it's only 1 electron withdrawing group. So can I say this is having least electron density, this is having most electron density among these 3. That's why 1 is stronger base, then 2, then 3. I hope this is clear till now. Let me know in the chats, am I clear till now? Let me know in the chats, am I clear till now? Exactly, Nityasri, exactly, it's 1, 2, and 3. That's good. So basically these 2 points are basically those points due to which you can say effect of substituent on nitrogen. If electron donating groups are attached to nitrogen, then more the number of electron donating groups, more will be the basicity. And if electron withdrawing groups are directly attached to nitrogen, then more the electron withdrawing groups, lesser will be the basicity, or weaker will be the base. Okay, this is clear. After that, dear students, sometimes we are having electron donating groups, but not attached to nitrogen, but attached to, say for example, this ring. I mean to say for example, this is electron donating group attached to either what we call ortho, meta, para, whatever position. Similarly, electron withdrawing groups are attached. Then in general, what will happen? So in general, electron donating groups increases the basicity and electron withdrawing group decreases the basicity. But there comes one more effect, and that is known as ortho effect. For that, I have simply taken this, photograph from a book so that you will understand it more nicely. Now, but before that, let me know in the chats, is this photograph clear to you? Is this photograph very much clear to you? So that I will try to make this understand. Let me know in the chats quickly. Is this clear? Is this photograph clear to you? Is this clear to you? Let me know quickly. Come on, dear students. Okay, that's great. That is great. Now, have a look. This is ortho substituted. These are ortho substituents or substituents present at ortho position of this aniline. Say, for example, we are having this aniline. This is aniline. After that, we are having, substituents present at ortho position, substituent present at meta position, and substituent present at para position. But for that, remember this aniline, it's given over here, its pKb value is 9.38. And remember, but before that, you must remember this one, that strength of base, if basic strength is increased, you know, at that time, remember, Kb is increased, which means pKb is basically decreased. And similarly, if basic strength is more, OH minus concentration, we can say it's more, that means POH at that time will be less. So it can be like this. Similarly, we can say if basic character is more, its acidic character or dissociation constant of acid, it will be lesser. That means pKa will be more. And similarly, if I mean to say Ka is less, pKa is more. Similarly, as this is, I mean, say strength of base, so basic character is more if H positive concentration is less. That means if pH is more, if pH is more. So we can simply say strength of base is directly proportional to Kb, inversely proportional to pKb, directly proportional to OH minus ion concentration, inversely proportional to POH, inversely proportional to Ka, directly proportional to pK, inversely proportional to H positive, directly proportional to what we call pH. Now here, what is the relation between strength of base and pKb? It's inverse relation, so have a look. If pKb is 9.38, that means if any amine, say base, whether it is ortho, meta or para, is having value greater than this, that means that base will be weaker base. If any among these is having lesser pKa value than this, that means that's having more stronger base than this. Say for example, when we put CH3 over here, its value is 9.62. But what is the value of this? Have a look. This is having 9.62, first value. This value is 9.38. That means this is having more pKb, that means lesser, I mean say, or weaker base. This is known as what we call ortho effect, because ortho effect says aniline is a stronger base than its ortho substituted anilines. So this is what we call ortho effect. I mean to say that the value of ortho substituted aniline should be greater than, I mean say pKb value of ortho substituted aniline should be greater than 9.3. So have a look over here. So this value is greater than 9.62. This value is greater than 38. This value is greater than 9.38. So all these three values are greater than 9.38. So that's why ortho effect is valid. But over here, its value should be lesser than, I mean say 9.38. But value is greater than it should be greater than 9.38, but value is lesser than 9.28, suggesting that whenever aniline is having ortho substituted aniline is such that OH is present at ortho position, at that time ortho effect is failed. Why is it so? Because what actually this means? It means aniline is more basic than this, means that conjugate acid of aniline is stronger or more stable always than the conjugate acid of, I mean to say, ortho substituted aniline. But in this case, say for example, if I write the conjugate acid of aniline, it is this one. And if I write conjugate acid of orthohydroxyaniline, it is like this. So according to ortho effect, have a look and listen carefully. According to ortho effect, this should be more stable as compared to this, but in reality, this is more stable because of chelation or intramolecular hydrogen bonding. That is why ortho effect is failed over here. So ortho effect is failed only and only when you are having OH group at ortho position. Otherwise, you can see this value is more than, I mean say this 9.38. This is also more than that. This is also more than that. More pKb value means lesser or weaker base. Similarly, this is, I mean say, greater than 9.38. That means weaker base. This is greater than 9.38 means weaker base. So this is the only value which should be lesser than 9.38, but this value this value should be greater than 9.38, but this value is lesser than 9.38, which clearly indicates that whenever aniline and orthohydroxyaniline, they are, I mean say, compared, at that time ortho substituted aniline which is having OH group at ortho position is stronger base as compared to aniline, and the reason is its conjugate acid is more stable because of chelation or intramolecular hydrogen bonding as compared to this. I hope this point is clear till now. Let me know in the chats quickly. Let me know in the chats quickly. Let me know in the chats quickly. Is this clear? Kanmani says crystal clear, sir. Thank you. God bless you. Okay. Kashvi. Yes. Okay. Okay, dear. Okay, dear. Come on, come on, come on. Let me know. Okay, clear, clear, clear. Okay. Muskan Wani, best teacher. Thank you, beta. Thank you very much. It means a lot. Okay. Shafkat, crystal clear, sir. Okay. Kambu. It's saying yes, yes, sir. Okay, not Nikki. Okay, yes, sir. Okay, so this is clear. So this is clear. So this is clear. After that, leave this and aniline. After that, you have to compare meta and para substituents now. Now, meta and para substituents now. Generally, when electron donating groups are attached, basic character will be more. Have a look. Its value is 9 only. Its value is 9. Here it's 9.33. Now, why value has been increased over here and why value is decreased over here? CH3 is electron donating. It donates more electron from para position as compared to meta because it shows plus I from meta and plus H from para, dominant factor. So it gives more electrons towards this nitrogen and increases electron density. But what about this one? What about this one? What about this? Have a look. Then it is like this. So this is more stronger base than meta, then ortho, if I compare these three, isomers without aniline. Otherwise, you can compare aniline as well. You can have a look over values and you can write down the answer. After that, this is having 8.71 because it donates electron due to resonance. After that, when it is present at meta, it becomes minus I group. It becomes minus I group. Now, have a look. Have a look. It should be, its value should be, lesser at meta and more at ortho. But why is it so? Because it is now electron withdrawing group. Electron withdrawing group decreases the basic character. That's why its value is more over here as compared to this one. Similarly, this is plus R group. This is here minus I group. But listen carefully, it is NH2. It's not other group. So aniline is already having one NH2. And when aniline, another NH2 group will come, that means two basic positions will be there. So remember, more basic positions, more will be the basicity. That's why this is more, basic. This is more basic, this NH2, as compared to aniline. Its value is lesser than aniline. Otherwise, if it is having another group which shows minus I, its value will be more as compared to aniline. But here, value is lesser. Why? Because it is NH2 group, which also acts as a base. So in meta-aniline, there are two NH2 groups. But in aniline, there is only one NH2 group. That means in aniline, only one basic position. In meta-aniline, there are two basic positions. So more the basic position, more will be the, basic character. So by simply having these values, you can draw the structures of these, amines, and you will simply write down their basic character in the correct form, and you will remember that. I hope this is clear till now. I hope this is clear till now. Let me know quickly so that we can move ahead and we will answer these questions. Let me know quickly. Let me know quickly. Am I clear till now? 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 Clear, clear, clear. Okay. So, Fida, what is the problem? Why not clear? Because these values are in front of you. So, any base having pKb value lesser is more stronger base. Any base which is having more pKb is, a weaker base. So, strength of base is inversely proportional to pKb. So, pKb values are here. So, you can write down the answer. So, this is very clear. It's very, very, very simple. Now, after that, let us try to answer these questions. Now, have a look. Have a look. Before answer these questions, you can also use this trick. You can also use this trick. What is the trick? Have a look. Basicity order, basically you can have a trick like this. First of all, use plus R, then plus H, then plus I, then that species which does not show either plus I, plus H, plus R, or minus I, minus H, minus R. That means normal or neutral. After that, you will use minus I, then minus H, and then minus R. First, over here, you have to write strong plus R first, then weaker plus R. Similarly, first strong plus H, then weaker plus H. First stronger plus I, then weaker plus I. So strong to weak. Here, you have to go like this, weak to strong. What is this? Have a look, we will use over here. Now, can I say this is benzene attached to, say NH2 attached to this phenyl ring, NH2 attached to phenyl ring, NH2 attached to phenyl ring. But the difference is here it is CH3, and we know from para position it shows plus I and plus H, but we know as distance is more, we generally don't take say inductive effect from this position. So the more dominant or predominant vector will be plus H. So our focus will be on plus H only. Similarly, this is minus I group as well as minus R, but our focus should be on minus R only as distance is more. Now, what is, say present over here? Here it is hydrogen. Hydrogen neither shows plus I nor shows minus I, neither shows plus R nor shows minus R, nor shows plus H nor shows minus H. So I will show this, I will write down this as N. So first of all, we have to write down plus R, but here no one is plus R. After that plus H. Which one is plus H? It is this one. It is this one. So I will write down 3. So 3 is the strongest base. After that plus I. No one is having plus I. After that N. This is N. That means after that I will write down 1. So this is the decreasing, increasing order. After that it will be 2. So 2 is the weakest base. After that 1 is strongest base and 3 is the strongest base. So either you will write down like this, or you will say that 3 is the strongest base. After that it is 1. After that it is 2. This is increasing order and this is decreasing order. Question answers are in decreasing order. So we will write down 2, 1 and 3. 2, 1 and 3. So this is the right answer. Let me know in the chats, is this clear? Let me know in the chats, is this clear? Very good, very good. 4 is the right answer. Many students have already written the answer. That's great. That is great. That is great. God bless you all. God bless you all. After that, we are having another question, and question is like the correct order of basic strength of methyl substituted amine. Methyl substituted amine in aqueous solution. We have discussed this before few minutes. So it will be simply 2 degree, then 1 degree, and then 3 degree. So this is 2 degree, 1 degree, 3 degree. So this will be the answer. So it is 2, 1 and 3. This is 3, no. This is 3, no. This is 1, no. So it is 2, 1 and 3 in aqueous solution. If methyl, if value of R is methyl, if amine is methyl substituted. Now, after this, let me know in the chats what will be the answer of this question. What will be the answer of this question? Question says that paramethyl aniline. I mean to say this one. Paramethyl aniline is this one. Paramethyl aniline is this. And aniline is this. Question says that paramethyl aniline is more basic than aniline. Reason. What is the reason? Why this becomes more basic than this one? Why this becomes more basic than this? Why paramethyl aniline is more basic than aniline? Tell me the answer. Which among these is the right option? Which among these is the right option? Come on, come on, come on. Let me know quickly. Come on, let me know quickly. Exactly. Second is the right answer, because this CH3, it shows plus I, it shows plus H. Plus H will be more dominant and plus I will be, weaker, but it shows. So first option is that it shows plus I effect only. No. Second option is it shows plus I as well as plus H. Good. Then it shows minus I. No, it shows minus H. Yes, it can simply show plus I as well as plus H. So this is the right answer. That's great. That is great. That is great. After that, next, Which of the following is the strongest base in gaseous phase? In gas phase, which of the following is strongest base? That is simply tertiary amine, then secondary amine, then primary amine, and lastly, it will be ammonia, because ammonia is always weaker base than aliphatic amines. This is very, very, very easy. After that, we will be having another. pKb values of 4 bases are given. Which is the strongest base? We know that basic strength and pKb, they are inversely related. So, any species which is having lesser pKb is stronger base. So, pKb values of 4 bases are given. Which is the strongest base? You have to check strongest base. Strongest base means its pKb value should be lesser. Now, tell me which one will be the right option. Lesser value, lesser value. It's 4.75, it's 3.38, 9.38, 10 point this. So this is the lesser value. Hence, pKb value is lesser, so basic character will be more. After that, which of the following is the strongest base? Come on, come on, come on, come on. Let me know in the chats what will be the answer. You have to find out the strongest base. You have to find out the strongest base. Which of the following will be the strongest base among these? Come on, let me know quickly. Let me know quickly. Let me know quickly, my dear lovely students. Come on, my dear doctors and engineers. Come on. Let me know the reason. Let me know the answer with reason. Quickly. Let me know the answer with reason, but quickly. Come on, come on. I'm waiting. I am waiting. I am waiting. Now, this is aryl amine. Nitrogen lone pair will take part in delocalization. So, this is delocalized lone pair. This is also a delocalized lone pair. What about this? This is alkyl amine. This is localized lone pair. What about this? Once again, a delocalized lone pair. Remember, whenever nitrogen is having localized lone pair, that is more basic as compared to delocalized lone pair. Why? Because when lone pair is delocalized, that means it is basically taking part in resonance. It's in conjugation with benzene ring. When it's taking part in what we call resonance, its electron density is not available for protonation. But it's not in conjugation. Its electrons are available for protonation. Hence, it becomes the most strongest base among them. So the strongest base among them is this one. So aryl amines and alkyl amines. Among aryl amines and alkyl amines, it is generally alkyl amines which are stronger bases. Let me know in the chats, am I clear till now? Let me know in the chats, am I clear till now? So that we will move forward and take another concept known as Gabriel phthalimide reaction. Let me know in the chats quickly. Am I clear till now? Am I clear till now? Okay, that's great. That is great. That is great. That is great. Come on. Let's have another concept or another reaction, and that is known as Gabriel phthalimide synthesis. What is this? Have a look. Whenever you are having phthalimide, whenever you are having this is known as phthalimide. This is known as phthalimide. But from which species this phthalimide has been obtained? Let me show you over here. Whenever you are having phthalic acid, whenever you are having phthalic acid like this, or you will simply write down COH, COH. So whenever benzene is having 2 COH groups at their ortho position, we call this as phthalic acid. We call this as phthalic acid. Whenever phthalic acid is treated with, remember, whenever it is treated with ammonia, whenever it is treated with ammonia, first of all, it will form ammonium salt over here, ammonium salt over here. After that, after heating, it will lose water molecule. When it loses water molecule, it becomes phthalimide like this. Have a look. It results in the formation of a phthalimide like this. C double bond O, and then it is NH2. Then C double bond O, it is NH2. But remember, my dear students, if this is once again heated strongly, I mean say upon strong heating, it loses simply NH3 and will result in the formation of what we call phthalimide. So this is actually our starting material in Gabriel phthalimide reaction. So this is the phthalimide. Now what will happen? When this phthalimide is treated with a base, say for example, alcoholic potassium hydroxide, what will happen over here? This base will simply abstract hydrogen and it will result in the formation of this one. So first of all, we will get potassium phthalimide. We will get potassium phthalimide like this. Now, after this, this is treated with Rx. And this is simply an SN2 reaction. This N minus will attack over this electron deficient carbon and this X will leave. But remember, this R can be 1 degree or 2 degree alkyl halide. It can be 1 degree or 2 degree alkyl halide. This R can never be a 3 degree alkyl halide. Similarly, my dear students, this R can be a structure like this C6H5CH2. I mean, say this R can be like this as well. So remember this R here, it is Rx, which is 1 degree or 2 degree alkyl halide. So Rx can never be tertiary alkyl halide, but Rx can be benzyl halide, or R value can be like this. That means this X should be attached to sp3, whether it is primary, secondary or benzyl halide. It can never be. R can never be an aryl group, because in this case X is attached to sp2 hybridized carbon and it never shows reaction. Similarly, R can never be a vinyl group as well. In nutshell, if R can never be this one, that means this will not show the reaction, this will not show the reaction, only this or this can show this reaction. So what will happen over here? Here it will result in the formation of like this, N and then R. After that, my dear students, we generally do hydrolysis in basic medium. Then what will happen over here? Simply this bond will break, give hydrogen to this and give minus to this. Say for example, let me write down over here NaOH. Let me write down over NaOH. So you can simply have a trick like this, give ONA to this, similarly break this bond, give H and ONA to this. Why ONA? Basically, it results first in the formation of acid, but in basic medium, acid becomes salt. So the product over here will be primary amine, and we will get sodium salt of phthalic acid. Sodium salt of phthalic acid. This is phthalic acid. But this H positive and H positive will be abstracted by base and it will result in the formation of sodium salt of phthalic acid. That means salt. Now have a look. We will get this one, in which functional group is NH2. That means primary amine. But this primary amine can never be an aniline. Why? This R can never be aryl group. So if it is never an aryl group, so aniline cannot be obtained in this reaction. Neither we can not get, CH2 double bond CH NH2, CH2 double bond CH NH2. We cannot get this. We cannot have, nitrogen attached to tertiary carbon, because tertiary alkyl halide also do not show this reaction. I hope this is clear to each and every one. After that, this last step, we can do this last step in this fashion as well. Here, hydrazine can also act as a nucleophile, and what will happen? It will attack on this and this bond will be broken. That means nitrogen is attached to this. But when it gives electron, it acquires a positive charge. Then it will lose H positive and that H positive goes to this. So give H to this. Similarly, this lone pair will attack this one and this one will be braked, give its hydrogen to this. So your product will be like this. It will be simply like this. C double bond O, this is C double bond O. One of the nitrogens from hydrazine is attached to this. Another nitrogen of hydrazine will attach to this. So we will get this one, plus we will get primary amine. So this is Gabriel phthalimide reaction. But in last step, you can do hydrazinolysis, that means lysis because of hydrazine, or you can carry out reaction known as hydrolysis. But remember, this is known as phthal hydrazide. But remember one thing. We can perform hydrolysis without catalyst as well, but that reaction will be slower. So say for example, we are performing hydrolysis without acid or basic medium. That means by using only H2O. Then remember, this hydrazinolysis is preferred over hydrolysis at that time, because hydrazinolysis, in this case, we use hydrazine as nucleophile, and in this case, we use at that time water as nucleophile if we not use NaOH there. Then instead of water, this is stronger nucleophile, then at that time, hydrolysis is not preferred, hydrazinolysis is preferred. So after that, have a look towards this question. Which of the following amines can be prepared by Gabriel phthalimide reaction? Gabriel phthalimide reaction gives primary amine but not amine, say aniline. So aniline is not the right answer. This is N-butyl amine. So this is the answer. N-butyl amine means this one. CH2, CH2, CH2. And then here it is NH2, here it is CH3. So this is a primary amine, so it can be formed, but this is also a primary amine, but this can never be formed. This is aniline, it can never be formed. So this is the answer. So is this clear till now? Am I clear till now? Let me know in the chats quickly. Okay, many of you have already given the answer. So what will be the answer over here? This is ethyl amine can be converted from N-ethyl phthalimide on treatment with. So have a look. So N-ethyl phthalimide means this one. N-ethyl phthalimide means this one. Et means ethyl. That means we have to break this bond, so that HH will be formed, added to this nitrogen. So this is ethylamine. So we get ethylamine from N-ethyl phthalimide with the help of which? NaBH4? No. With the help of hydrogen? Yes. With the help of water? Yes. With the help of CaH2? No. But if you have to choose only one at that time, as this water is without acid or base, at that time, this will be the right option. But otherwise, both are correct. Both are correct. After that, we have assertion reason question. Aniline cannot be prepared by Gabriel phthalimide synthesis. Aniline cannot be prepared by Gabriel phthalimide synthesis. Exactly correct. After that, aryl halides do not undergo nucleophilic substitution with aniline formed by phthalimide. Exactly correct. Aryl halides do not show this reaction, and aniline can also not be prepared. So that means both A and R are true, and R is the correct explanation of A. That means first will be the right answer. Now, let me know quickly, am I clear till now? Let me know quickly, am I clear till now? Am I clear till now? Okay, am I clear till now? Am I clear till now? Let me know quickly, my dear lovely students. Come on, come on, come on, come on. Meena, thank you. Kanmani, thank you. Kashvi, thank you. Shamla, thank you. Thank you, thank you, thank you all. Okay, after this, we are having another concept and a very, very, very important reaction. This is known as Hofmann bromamide degradation reaction. But there is some issue in light supply, so that there will be no problem. Let me switch off few lights so that there will be no issue at all. I hope everything is clear. Everything is clear. Is board clear to you? Is this board clear to you? Is this board clear to you? Is this board clear to you? Let me know quickly. Let me know quickly. Is this board clear to you? My dear lovely students, let me know quickly. Okay. Okay, beta. Okay, beta. So what is Hofmann bromamide degradation reaction? Say, for example, we are having either aromatic or aliphatic amide. When these amides are treated with, either bromine and NaOH, or bromine and KOH, or NaOBr, say sodium hypobromite, or KOBr, that means potassium hypobromite. What will happen? What we have to do is, we have to remove simply this C double bond O. Remove C double bond O, then we will get an amine like this. So we will get a primary amine over here during this reaction, but this primary amine is having one carbon lesser as compared to this amide. One carbon lesser as compared to this amide. This is the reaction. But if you want to balance this reaction, then reaction is like this. So you can write down reaction like this. You can write down 4 times NaOH, 4 times KOH. Okay. Anyone? After that, you just remove this one. That means you will get ArRNH2. That means primary amine. From amide, you will get primary amine. And in addition to this, you will get Na2CO3. That means CO3 2 minus. This carbon is basically removed from amide in the form of CO3 2 minus ion. And after that, you will get twice NaBr plus twice water. So our oxygen balanced 3, 2, 5, 4 and 1, 5. Yes, this is the balanced reaction. Now, what this reaction actually takes place? I mean, say, what is the mechanism of this reaction? Let me show you the mechanism, because mechanism of this reaction is very, very, very important, because questions can be asked from that mechanism portion of this reaction. So have a look. Have a look. This is the mechanism for this reaction. Have a look. Reaction mechanism is like this. Suppose, first of all, you are having RCO and NH2. Can I write NH2 in this fashion? Then we are having base, say for example, OH minus. Then what will happen? Then what will happen over here? What will happen over here? This base will abstract H, and first of all, it will result in the formation of RCONH having negative charge, amide ion. Then this reacts with Br2. It reacts with Br2, and first of all, it simply results in the formation of N-bromamide. It results in the formation of N-bromamide. This is the first intermediate of this reaction, remember. So this is the first intermediate. So this is intermediate first of this reaction. After that, what will happen? This intermediate now is treated with base. A base will abstract its hydrogen, and it will result in the formation of N-bromamide ion. N-bromamide ion. After that, have a look. After that, we can write down like this. We will say that this Br minus will lose. If Br minus is lost, it will result in the formation of this one. This is known as acyl nitrene. Or we can say Br will lose this carbon or this alkyl part or aryl part, depending upon whether it is ArCONH2 or RCONH2. Then this will migrate from this carbon to nitrogen, electron deficient nitrogen. Then this nitrogen lone pair will form a double bond over here. So it's R bonded with nitrogen now, and this nitrogen forms a double bond with carbon and carbon with oxygen. Remember, sometimes we directly show this, from this to this, Br minus is lost. Loss of Br minus from this N-bromamide ion is rate determining step. Either this is the rate determining step, or you can say this is rate determining step, depending upon whether we say that reaction takes place via acyl nitrene or directly what we call migration of this R or AR, that means rearrangement takes place directly. So this is intermediate number second, and this is intermediate number third. But if this acyl nitrene is obtained, it will result in the formation of rearrangement. And this rearrangement takes place within the molecule. This is known as intramolecular rearrangement. So here, intramolecular rearrangement takes place. So intramolecular rearrangement takes place over here, or you can simply say Br minus is lost and intramolecular rearrangement takes place in this. Now, after that, finally, we will get alkyl isocyanate. And this alkyl isocyanate upon, say hydrolysis now, with respect to or with the help of this base, say for example, finally you have to break this one, add hydrogen, 2 hydrogens over here, and add what we call O minus over here and O minus over here. I mean to say we will get RNH2 plus CO3 having 2 negative charges. But if I take NaOH over here, then it is Na2CO3. If I take KOH over here, then it is K2CO3. So this is the mechanism that carbon is lost in the form of CO3 2 minus ion. And intermediate of this reaction is either bromamide or what we call alkyl isocyanate or what we call acyl nitrene. But one more point, this is not from this reaction. This is an information to you that if we are having like this CH3 N double bond C double bond O. This is known as methyl isocyanate, and remember methyl isocyanate was responsible for Bhopal gas tragedy. This was responsible for Bhopal gas tragedy. This is an extra point to you. This is responsible for Bhopal gas tragedy which takes place in 1984. So this is an extra point, so I will simply put it in a box over here. So this was what we call Hofmann bromamide reaction. I hope this is clear to each and everyone there. If this is clear, then you can write down the answer of these questions quickly. You can answer questions now very, very, very quickly. Question is, in Hofmann bromamide degradation reaction, the number of moles of NaOH and Br2 used per mole of, amine produced. Now, let me know. Have a look over here. Have a look over here. Balance reaction is this. So for 1 mole of amine, we need 1 mole of bromine and 4 moles of NaOH or 4 moles of KOH. Now, question says how many moles of NaOH and how many moles of Br2? So it is 4 moles of NaOH and 1 mole of Br2. So second option is the right answer. Second option is the right answer. Love from Kashmir. Thank you very much. Thank you very much, Akibas. Thank you, beta. Okay. Okay, that's great. That's great. That is great. That is great. Now, after that, we will be having another, question over here. In Hofmann bromamide degradation reaction, the carbon atom of amide group is lost as. Carbon atom of amide group is lost as CO3 having 2 negative charges. Carbonate. So this is the right answer. This is the right answer. After that, we will be having another reaction. Another question. An organic compound A on treatment with NH3 gives B. B on heating gives C. C is treated with Br2KOH, produces ethylamine. Now, what is the compound A? So, among these, compound A is either this one, this one, this one, or this one. That means compound A is carboxylic acid. So, let us say it is RCOH. Then, this A, this is the compound A. Now, what question says is that on treatment with NH3, that means when it is treated with NH3, we know this is acid, this is base, it results in the formation of ammonium salt. Ammonium salt. That means this is B. After that, B on heating gives C. Now, this B upon heating loses water molecule, results in the formation of RC double bond O NH2. That means amide. So this is C. After that, this C is treated with Br2KOH. That means Hofmann bromamide reaction. Br2KOH. Now, what we have to do is we have to remove C double bond O. When we remove C double bond O, we get RNH2. So, it's saying that it produces ethylamine. We have the value of R in our question is simply ethyl. That means this is R is having a value CH3CH2. So we started from this. That means what is this R? At that time it is CH3CH2 and then this COH. So this is what we call A. So have a look and tell me what is A. A is this one. This is very, very, very easy question. Let me know quickly. Am I clear? Let me know clear. Let me know quickly. Am I clear? Am I clear? Am I clear, my dear students? Am I clear till now? Exactly. It's CH3CH2COH cashew at the rate of cashew. Exactly. That's great. Nice. That's great. Clear, everyone. After that, we will be having another question. Hofmann bromamide degradation is an example of. Hofmann bromamide reaction is an example of what? Intramolecular rearrangement. That means it is, just give me a second, because something is wrong with my, say this laptop. It's showing that leave your device on unplugged. Okay, we need an R at least. Okay, so Hofmann bromamide degradation is an example of nucleophilic addition? No. Electrophilic substitution? No. Free radical substitution? Answer is no. Then it is an intramolecular rearrangement? Answer is yes. Answer is yes. After that, my dear students, statement 1. In Hofmann degradation, the migration of an alkyl group takes place from nitrogen atom to the carbonyl group. Have a look, have a look, have a look. From nitrogen atom to carbonyl group. Have a look. Is this migrating from nitrogen to carbon? No, it is migrating from carbonyl group to electron deficient nitrogen. Now tell me, is our statement correct or wrong? Can I say this first statement is incorrect? After that, the group migrates to an electron deficient nitrogen. Yes, this is correct. So first statement is incorrect, second is correct. First is incorrect, but second is correct. So it is fourth one. So first is incorrect, second is correct, fourth one is the right answer. After that, which step is the rate determining step in Hofmann bromamide degradation? Which step? Which step is, I mean to say, rate determining step? Have a look, have a look, have a look. Have a look towards mechanism. This is rate determining step. I mean say, when Br minus is this leaving of Br minus is rate determining step. Either this is rate determining step. That means either formation of acyl nitrene, or we can say formation of alkyl, what we call isocyanate, is the what we call rate determining step. So rate determining step is either formation of acyl nitrene or isocyanate. That means this one. That means this one. But remember, rate determining step is basically leaving of Br as Br minus. Okay. After that, we will be having another very important reaction, and that is carbylamine test. What is carbylamine test? Have a look. Whenever aromatic or aliphatic amine, but which one? Primary amine. Whether aliphatic, whether aromatic or amine should be primary amine. On treatment with chloroform, in presence of base, reacts together, it results in the formation of isocyanide. So this is isocyanide which is formed. Its another name is isonitrile which is formed. Or its another name is, my dear students, carbylamine. And it is having an unpleasant, odor. Unpleasant odor, or we can say simply, it's foul smelling or foul, what we call odor. It's having foul smell or foul odor. So this is formed. So foul odor or unpleasant odor is because of isocyanide, isonitrile or carbylamine. So if we are having a doubt whether our test tube contains primary amine, secondary amine or tertiary amine, so we will simply put chloroform and KOH with it. If foul smell is there, then we will say carbylamine is formed. That means our amine is basically primary amine, and this reaction can be used as a test to distinguish primary amine from rest of the amines under the name carbylamine test. Plus, we will get 3 times KCl over here and 3 times water. Now, what is the mechanism of this reaction? Have a look. Its mechanism is very, very simple. Let me show mechanism of aliphatic primary amine, but instead of R, you can use AR afterwards. Now, so this is primary amine. It first reacts with dichlorocarbene. Sir, dichlorocarbene, but we don't have dichlorocarbene. Basically, these two will react together. These two will react together in this fashion. Say, for example, OH minus will simply abstract H from chloroform, and it will first result in the formation of a carbanion, and after that, it will lose Cl and results in the formation of a dichlorocarbene. So this dichlorocarbene will act as an electrophile during this reaction. Now, this will attack over this. So what will happen? What will happen? It is very, very simple, my dear students. It is like this: NHH with a positive charge, and then this Cl having negative charge. This will abstract this H, and it will result in the formation of, this. It will simply give us this one. And then it is CH, Cl, Cl. After that, it will form a double bond. Cl will leave. Have a look. Cl is lost, and we will get R and H, double bond CH, and then Cl with a positive charge. After that, base will come. Base will abstract this hydrogen, and it will simply becomes R and double bond C. Then it is H, then it is Cl. After that, this lone pair once again forms a triple bond over here, and Cl will leave. Cl will leave. When Cl leaves, it results in the formation of R and triple bond C with a positive charge and H over here. Once again, base will come. Base will abstract this hydrogen, and we will get what we call isocyanide or carbylamine. But mechanism is now not necessary for you. You have to look the mechanism, and you have to remember that dichlorocarbene acts as what we call an electrophile over here, and final product is isocyanide or isonitrile or carbylamine, and it is due to this isocyanide, isonitrile or carbylamine that unpleasant odor is there. I hope this is clear. After that, which of the following will give carbylamine test? Which amine gives carbylamine test? It is primary amine, whether aliphatic or what we call aromatic. So it is primary amine which shows carbylamine test. So where primary amine is, this is NH2 primary amine, this is secondary amine, this is tertiary amine, this is amide. So we will be having simply primary amine. After that, the false smelling compound formed in carbylamine reaction is, it's not cyanide, it is isocyanide. This is nitrile, this is nitrosamine, so it is isocyanide. Very, very, very easy. After that, my dear student, the reaction of aniline with chloroform in presence of alcoholic potassium hydroxide produces. Have a look. Aniline is this one. Aniline is this. On treatment with chloroform and alcoholic potassium hydroxide, it results in the formation of what? Results in the formation of this product. Then it is 3 times KCl and 3 times water, because we know it's this NH2 group which is changed to NC group. So this is isocyanide. So this is phenyl isocyanide, which is the product. So phenyl isocyanide is the product of this reaction. Chloropicrin means this one. CCl3NO2. No, this is not the product. Benzene diazonium chloride is this one. So this is not the product. N2 and Cl minus. So they are not the product. So this is the product. This is phenyl cyanide. This is not the product. So we will simply say phenyl isocyanide will be the product. After that, dear students, another question is a compound X with molecular formula, this one, gives a positive carbylamine test. That means this is simply an amine. But it can never be an aromatic amine because carbons are only 3. So this is aliphatic primary amine. What is the likely structure of amine? Say this one. We know this is aliphatic primary amine. So among these, I have written N, I have written 2H. So it becomes, this R is now C3 and H7. This R is C3H7. Now, have a look. This is tertiary amine, so it can never be the option. This is a secondary amine, and that too having only 2 carbons. So this is not the option. This is a secondary amine. This is not the option. So this is our amine, say C3H7, like CH3, CH2, CH2, NH2. This is the right answer. After that, we have another test, very important test, and that is known as Hinsberg's test. This is known as Hinsberg's test. Have a look. What is Hinsberg's test? First of all, this is used. It's used to distinguish. It is used to distinguish 1 degree, 2 degree, and 3 degree amines. It's used to distinguish 1 degree, 2 degree, and 3 degree amines. Now, what is the test? Have a look. We use basically benzene sulfonyl chloride, and we treat it with primary amine. What will happen? This primary amine will attack on this, Cl minus will be lost. That Cl will react with H, and it will result in the formation of a solid, and that solid is like this. That solid will be like this, and its name is simply N-alkyl benzene sulfonamide. So this is the product. This is 1 degree amine, and this is known as benzene sulfonyl chloride, and this benzene sulfonyl chloride acts as Hinsberg's reagent. Benzene sulfonyl chloride acts as Hinsberg's reagent. So when Hinsberg's reagent reacts with primary amine, it first results in the formation of N-alkyl benzene sulfonamide. But if this is treated with alkalis, or say for example KOH, a base, this base will abstract this hydrogen. As this hydrogen is acidic hydrogen, so base will abstract this, and it will result in the formation of this S double bond O, then it is Nr having negative charge, and K positive will attract to this negative charge. I mean to say, this is K positive, this is K positive. I mean to say that this solid is basically soluble in alkali. Now, tell me, whose solid is soluble in alkali? It is the solid formed from primary amine when treated with Hinsberg's reagent. After that, if same Hinsberg's reagent is treated with or reacted with secondary amine, now what will happen over here? It will simply react together, and they will result in the formation of NN dialkyl benzene sulfonamide. NN dialkyl benzene sulfonamide. But this benzene sulfonamide is not having any, say acidic hydrogen. So there will be no reaction on treatment with alkali. So there is no reaction. So there is no reaction on treatment with alkali. Give me a second as light came. So we can switch on once again these lights. Okay. So there is no, formation of any product. There is no reaction. So can I say this solid is actually insoluble in alkali? It's insoluble in alkali. Now, whose solid is soluble in alkali? Primary amine. Whose solid is insoluble in alkali? That means of secondary amine and, Hinsberg's reagent. That means of secondary amine. And remember, this Hinsberg's reagent, when treated with tertiary amine does not react with this. That means there will be no reaction, as this is not having any hydrogen. So with the help of this, we can distinguish whether our starting material is primary amine, secondary amine, or tertiary amine. That's why this is known as Hinsberg's test. Now, let me know in the chats what will be the answer of this question. This is very, very, very easy now. Let me know quickly what will be the answer of this reaction. Let me know quickly what will be the answer of this reaction now. Let me know. Okay, 3 degree, no reaction, sir. Yes, there will be no reaction. Exactly, there will be no reaction. So what will be the answer of this? Now the question is, amine that reacts with Hinsberg's reagent to give alkali insoluble product. Have a look. Insoluble product is, that is of amine, say secondary amine when reacts with Hinsberg's reagent. Have a look, have a look, have a look. So what will be the answer? This is secondary amine, this is primary amine, this is primary amine, this is tertiary amine. So we will simply write down the answer this. This is the right answer. This is the right answer. Exactly, exactly, exactly. Now, after that, identify the compound that will react with Hinsberg's reagent to give solid which dissolves or soluble in alkali. That means it should be a primary amine. This is nitro compound. No, this is secondary. This is primary and this is tertiary. No. So this is the right answer. But let me tell you one more thing. That means the Hinsberg's reagent used was benzene sulfonyl chloride. But nowadays that benzene sulfonyl chloride is replaced by paratoluene sulfonyl chloride, that is also known as tosyl chloride. That is also known as tosyl chloride. But before that, have a look. Hinsberg's reagent is used to distinguish between primary, secondary and tertiary amines. Very, very, very easy question. Now, that means when you know organic chemistry, to answer the question of organic chemistry, it takes very, very, very less time. But only you should know organic chemistry. That's the only thing. Now, after that, which of the following is preferred over benzene sulfonyl chloride? Remember, it is this one. It is this one which is preferred. Paratoluene sulfonyl chloride. This is preferred, or this is used nowadays. This is known as paratoluene sulfonyl chloride. So this is preferred or used instead of benzene sulfonyl chloride nowadays. This is also known as tosyl chloride. So you can remember the name of this species which is preferred over benzene sulfonyl chloride. So benzoic acid no, nitrobenzene no, phenol no. So this is tosyl chloride. After that, we will be having another important reaction that is known as diazotization reaction. But before that, before starting diazotization reaction, let me know quickly, my dear students, am I clear till now? Am I clear till now? Am I clear till now? Yes, that is the NCERT line. Exactly, that's the NCERT line. And NCERT is very, very, very important for you. Yes, that is the NCERT line, that we use tosyl chloride or paratoluene, what we call sulfonyl chloride instead of benzene sulfonyl chloride. Yes, that is the NCERT line. Great. After this, we are having diazotization. What is diazotization reaction? Whenever you are having a primary aromatic amine, aromatic primary amine, like aniline, say for example, when this is treated with, I mean to say NaNO2, sodium nitrite, in excess of acid, what will happen? It will result in the formation of nitrous acid, and excess of acid is there, and reaction takes place at a temperature of 0 to 5 degrees Celsius. So we get at that time benzene diazonium salt. Benzene diazonium salt. Say for example, we are having HCl, so salt will be benzene diazonium chloride. So that reaction during which primary aromatic amine on treatment with sodium nitrite HCl at 0 to 5 degrees Celsius, or primary aromatic amine with nitrous acid in acidic medium at 0 to 5 degrees Celsius results in the formation of benzene diazonium salt, is known as diazotization reaction. This is known as diazotization reaction. But remember, this benzene diazonium salt is stable only up to 5 degrees Celsius. That means it is not stable if temperature is greater than 5 degree. What is 5 degree? 5 degree means 298 Kelvin. If temperature is more than 298 Kelvin, it is not stable at that temperature. Remember. Now, second point, very important point of this is mechanism of this reaction. Have a look. Another important point of this reaction is the mechanism of this reaction. Actually, what happens over here is we are having nitrous acid. it reacts with acid, I mean say positive part of acid, and it first results in the formation of this one. It results in the formation of OH with a positive charge, and this is a good leaving group. Now it will lose, this leaving group will be lost, and after this it will result in the formation of NO with a positive charge, nitrosonium ion. Now after that I will write down Ar instead of phenyl ring or benzene ring. Now this ArNH2, I mean say aromatic amine, will now attack on this. That means it donates electron, it will act as a nucleophile, so it will give its electron to this, and it will result in the formation of ArNH with a positive charge, and then it is having N double bond O. I hope this is clear. This is very much clear. After that, H positive will be lost. H positive will be lost, and this nitrogen becomes neutral nitrogen, and that H positive will be abstracted by this. So let me show you both the steps over here. So can I say proton transfer takes place? After this, it will result in the formation of Ar, then NH. This is having lone pair, then it is N, then it is double bond O, then it is single bond H, and this is having a positive charge. This is having a positive charge. Now, have a look, dear students, have a look. Can I say its resonating structure can be like this? Can I say its resonating structure can be like this? R, NH with a positive charge, then double bond N, single bond OH, having a lone pair over here. After that, I will simply say this will lose H positive, and that H positive can be abstracted by this oxygen, and finally once again a proton transfer will take place, and it will result in the formation of Ar, then N, then double bond N, then it is OH with a positive charge over here, and one lone pair is there. So what will happen? This becomes a good leaving group, and it will leave, and it will result in the formation of this one. So leaving group will, I mean say leave, that means water will be lost, and it will result in the formation of a diazonium ion. It will result in the formation of a diazonium ion. Now, if Cl minus is there, acid, negative part of acid, that will come over here. Attraction will be there between this positive and that. So we will get benzene diazonium salt. I mean to say, this benzene diazonium salt or this diazonium ion is only prepared if this nitrogen donates its electrons. So remember, it should donate its electron. So more the donation, more faster will be the reaction. Lesser the donation, I mean say rate of reaction at that time will be less. I hope this is clear till now. Let me know in the chats. Let me know in the chats quickly. Am I clear? Am I clear? Is this mechanism clear to you? Is this mechanism clear to you? Let me know in the chats quickly. Let me know in the chats quickly. Nitya Sri is saying clear, sir. Meena Amu clear. Kamala clear. Kashu clear. Okay, Kanmani clear. It's me, Santosh Kumar, clear. That's great. That's great. That's great. That is great. That is great. Okay. Savage Medic. It says, yes, sir, it's clear. Okay, that's great. That's great. That's great. Now, have a look and tell me the answer of these questions. The diazonium salts are the reaction product in the presence of excess mineral acid. Mineral acid means it can be, I mean, say HNO3, it can be HCl, and nitrous acid with primary aliphatic amine. No. Secondary aromatic amine, answer is no. Primary aromatic amine, answer is yes. Because it is the primary aromatic amine which forms benzene diazonium salt, which are stable at, I mean, say 0 to 5 degrees Celsius. So this is the answer. After that, the product formed from the following reaction sequence. Have a look. Have a look. So it is like this. First of all, we will be having like this. Benzonitrile. Benzonitrile on treatment with lithium aluminium hydride and water. What will happen? So it will result in the formation of HNH2NH2. That means it is simply primary amine formation first. So it will result in the formation of CH2NH2, primary amine. Primary amine. Have a look. This is primary amine. After that, now this primary amine, nitrogen is attached to sp3. Nitrogen is attached to sp3 carbon. Here. Here, nitrogen is attached to sp2 hybridized carbon. If nitrogen is attached to sp2 hybridized carbon, diazonium salt will be formed or diazonium ion will be formed. But if nitrogen is attached to sp3, then it will undergo a carbocation mechanism like this. So when on treatment with NaNO2, remember, in presence of HCl and 0 to 5 degrees Celsius, remember here salt formation first takes place, but that is not stable. And remember, you have to remove this and you have to put OH over here. So its product will be CH2 and then OH. I mean, say benzyl alcohol. Benzyl alcohol will be obtained. No, no, no. This will be the product. So remember, this is not the product. Why? Because here nitrogen is attached to sp3. Whenever NH2 is attached to sp3, that primary amine always result in the formation of alcohol as major product. So that is alcohol which is formed, aromatic alcohol is obtained. Am I clear? Am I clear till now? Am I clear till now? Do you know this? Am I clear till now? Am I clear till now, my dear students? Am I clear? Am I clear? Let me know quickly. Let me know quickly. Today's session is not that longer as previous two sessions were. Okay. Clear, clear, clear. After that, we will be having another question, that is para-nitroaniline. Para-nitroaniline is this one. It is para-nitroaniline. It is this one. It is this one. That means this is electron withdrawing group. This is an electron withdrawing group attached to aniline. This is aniline. Para-nitroaniline is less reactive. This is less reactive towards aniline than aniline towards diazotization. Why is it so? Look towards the mechanism. Look towards the mechanism. If we are having phenyl ring over here, that means aniline. In another case, we are having electron withdrawing group. So what will electron withdrawing group do? That will withdraw electrons and that will decrease the electron density of this. So if electron density of this is decreased, attack will be slower. Attack slower means that will be less reactive, I mean say amine. So now tell me, why is it so? Less reactive. Why this is less reactive than aniline? Reason is because of presence of electron withdrawing group. So NO2 group donates electrons? No. NO2 group withdraws electrons by resonance? Yes. NO2 group increases basicity? No. NO2 group makes the diazonium salt more stable? No. NO2 group withdraws electrons. Because of that, this electron density of nitrogen will be decreased and it will not attack more easily as this nitrogen attacks on NO positive, I mean say nitrosonium ion. After that, given below are two statements. Statement 1, primary aliphatic amines react with nitrous acid to give unstable diazonium salt. Yes, yes, because this is primary amine. On treatment with NaNO2 HCl, or any acid, or HNO2 acid, 0 to 5 degrees Celsius, 0 to 5 degrees Celsius, first results in the formation of this one. But remember, this is highly unstable. That's why this bond will be broken and a carbocation will be formed. So N2 will be lost, carbocation will be formed. So rearrange if possible. Finally, this carbocation results in the formation of alcohol. That means this is unstable, highly unstable. So first step is, I mean say statement first is correct. Primary aromatic amines react with HNO2 to form diazonium salts, which are stable even, no, this is wrong. They are stable up to 298 Kelvin, not above 300 Kelvin. That means statement first is correct, statement second is incorrect. Statement first is correct, statement second is incorrect. Statement first is correct, statement second is incorrect. So fourth option is the right answer. Fourth option is the right answer. Let me know quickly, am I clear? Let me know quickly, is this clear to you? Is this clear to you? Let me know quickly, quickly. Let me know. Let me know quickly. Yes, that's great. Fourth is the right answer. Fourth is the right answer. Exactly, fourth is the right answer. After that, we will be having another two important reactions. One is Sandmeyer, another is Gattermann. Have a look. What is Sandmeyer reaction actually? It is a reaction of, it's a reaction of benzene diazonium salt. Benzene diazonium salt. It is reaction of benzene diazonium salt. Have a look. It is a reaction of benzene diazonium salt with cuprous halide or cuprous halide in presence of HX, or we can say CuX in presence of HX. X can be either Cl or it can be Br. So resulting in the formation of what we call either chlorobenzene or bromobenzene, because value of X is Cl. Similarly, this benzene diazonium chloride on treatment with CuCN, KCN, here this N2 will be replaced by cyanide, so benzonitrile can also be produced. So this reaction, with the help of which you can form chlorobenzene, bromobenzene by cuprous halides, or you can form benzonitrile by cuprous halides and a Cu positive ion. So this reaction is known as Sandmeyer reaction. So this is Sandmeyer reaction. So this is what we call example of Sandmeyer reaction. This is Sandmeyer reaction. So what is Sandmeyer reaction? A reaction of benzene diazonium salt with cuprous halides, that means Cu positive, or cuprous cyanide, that means Cu positive, resulting in the formation of either chlorobenzene, bromobenzene, or benzonitrile. This is what we call Sandmeyer reaction. Another is Gattermann reaction. What is Gattermann reaction? Have a look. Whenever you are having benzene diazonium salt, say for example benzene diazonium chloride, upon treatment with copper powder, instead of cuprous, it is copper powder in presence of, say for example HX, let us suppose X is Cl or Br, then we will get, say chlorobenzene or bromobenzene in this reaction as well. But there is no cyanide formation in this reaction. Second point, haloarenes, very, very important point written in NCERT. Haloarenes obtained from Sandmeyer's reaction are present in high yield as compared to Gattermann's reaction. That means if we prepare chlorobenzene and bromobenzene with the help of Sandmeyer reaction, yield will be more. If we prepare chlorobenzene or bromobenzene with the help of Gattermann reaction, yield will be less. So can I say, to prepare chlorobenzene or bromobenzene, Sandmeyer reaction is preferred over what we call Gattermann's reaction. This is an important point you must remember. After that, let us have few questions on these two reactions. When benzene diazonium chloride is treated with, this is cuprous ion is there, Cu positive is there. In presence of HCl, chlorobenzene is formed. Reaction is known as, whenever reaction takes place by cuprous ion, reaction is Sandmeyer reaction. After that, the correct statement regarding the difference between Sandmeyer and the Gattermann reaction is, Sandmeyer reaction uses copper powder. No. Gattermann reaction gives better yield. No. Sandmeyer reaction uses cuprous salts, while as Gattermann uses copper powder. Exactly correct. This one is the correct answer. After that, which of the following nucleophiles can be introduced into the benzene ring via Sandmeyer reaction? Have a look. We can introduce Cl minus, we can introduce Br minus, or we can introduce Cn minus. That means which nucleophiles can be introduced with the help of Sandmeyer reaction? It can be Cl minus, it can be Br minus, it can be Cn minus. That means 1, 2, and 3. So 1, 2, and 3 is the right answer. After that, we will be having another concept. This is known as coupling reaction. Very, very, very important concept. Have a look. What is coupling reaction? It's basically two types of compounds. One is phenol, another is aniline. Phenol or aromatic amine reacts with benzene diazonium salt. That means there are two types of coupling reactions. Number one is, have a look. Number one is, whenever you are having benzene diazonium salt, say for example this one, this is a benzene diazonium salt, or you can write down a triple bond over, then positive charge will be over this. So benzene diazonium salt on treatment with phenol, have a look. Coupling takes place, but when it couples with phenol, coupling takes place generally in basic medium. That means pH 9 to 10 is required, or you can simply say in presence of base. Now, coupling takes place and this benzene diazonium ion is attached to this phenol at para position. So we will get like this. We will get a di known as azo di. We will get a di known as azo di, and this azo di is known as 4-hydroxy azobenzene or para-hydroxy azobenzene. 4-hydroxy azobenzene or para-hydroxy azobenzene is obtained, and its color is orange, and as it is a dye, so we can simply say orange azo dye or orange dye is obtained. Now, this reaction can be used to distinguish phenol from alcohols, because alcohols will not show this, say color, phenols will show on treatment with benzene diazonium salt. This is first. Second one is, let me show you second over here. Second is, if this benzene diazonium salt reacts with aromatic amine, say for example aniline, it finally reacts, or this diazonium ion is finally coupled with this aniline at para position, but this reaction takes place at a pH of 4 to 5. That means generally we can say in acidic medium this reaction takes place, and it results in the formation of once again a di, azo di, and this azo di is known as 4-amino azobenzene. 4-amino azobenzene. That was 4-hydroxy azobenzene. This is 4-amino azobenzene. This is azo di. This is also azo di, but that is having orange color. This is having yellow color. So at which place this coupling takes place? At para position of phenol or at para position of, say aniline. But if para position does not have any hydrogen, instead of hydrogen there is a group, we simply say para position is blocked. Similarly, if this para position is not having hydrogen, some other group is there, we simply say para position is blocked. I mean to say, if para position is blocked, say for example para position is blocked. Suppose this is aniline, its para position is blocked. This is phenol part, its para position is blocked. Then what will happen? Then what will happen if it is treated with? If it is treated with, have a look. If it is treated with, I mean to say benzene diazonium salt. Now, what will happen? Have a look. This is what we call benzene diazonium salt. I will write down directly pH N2Cl having a negative charge. This is pH N2Cl having a negative charge. Now, N2pH is attached to para. Now, we have to attach N2pH to para, but para is blocked. So, if reaction takes place in basic medium, we will simply couple this with phenol. Say coupling of phenol will take place, but para position of phenol is this one. This is blocked. So this N2pH will not go to para. It will now go to ortho position. That is why product over here will be OH NH2. But now this N2pH will come, but it will come to para position. But with respect to OH, why? Because reaction takes place in basic medium. In acidic medium, when reaction takes place in acidic medium, then reaction takes place according to NH2 group. That's why N2pH will be, attached to this benzene ring or phenyl ring, but at ortho position with respect to NH2, as this is acidic medium reaction. Now, the question is, which type of reaction is this? Which type of reaction is this? Have a look. I will show you the mechanism a little bit. Mechanism I will show you. Have a look. Have a look. This is N double bond N having a positive charge. Now, this is benzene diazonium ion. It reacts with, say for example, phenol. Have a look. What will phenol do? Phenol will, this oxygen will donate its electron towards the ring, and it will increase electron density either at ortho or at para. But para one will be the major product. I will show the mechanism of para. Now, can I say, now para becomes negatively charged, then this para will attack to this. That means coupling will take place at para position. So can I say this benzene diazonium salt, this benzene diazonium ion acts as an electrophile? Because this is electron rich site, this electrophile will attack to electron rich site. Now, this acts as an electrophile. Now what will happen? This acts as an electrophile and it will simply be, introduced at para position of phenol. At para position of phenol. Have a look. Will be introduced to para position of phenol like this, because this is already having one hydrogen. So this acts as an electrophile. So this is the electrophile of the reaction. And this electrophile is introduced at para position. After that, this para hydrogen will be lost. Para hydrogen will be lost. If para hydrogen is lost, can I say instead of hydrogen, this electrophile is attached, this benzene diazonium ion, this electrophile is attached to, para position of phenol. So instead of para hydrogen, benzene diazonium ion has been attached to para position. So this is simply electrophilic substitution reaction of phenol, in which this acts as an electrophile. Similarly, if you remove this by NH2, same reaction will take place. In nutshell, coupling reaction is electrophilic substitution reaction, in which this benzene diazonium ion will act as an electrophile. I hope this is clear to you. But basic medium basically helps in this reaction, that catalyzes the reaction. Why? Because whenever you take a base, that will abstract this hydrogen. When it abstracts hydrogen, it becomes phenoxide ion. That means its nucleophilic character will be increased. So more the nucleophilic, a center will be here, reaction will be more faster. Because when OH is neutral, instead of that, you will take O minus. OH will donate electron to ring and increase electron density of the ring, but O minus will increase more electron densities, because negative charge present on oxygen becomes more electron donating. So this is electrophilic substitution reaction. And which type of, molecules can show more electrophilic substitution reaction among these two? Whether it is this one, which type of, compound will show this coupling reaction faster? Which of these two show coupling reaction faster? Let me know in the chats and tell me the reason. Have a look. This nitrogen will donate electron density. Electron density is increased, it will attack diazonium ion, and our diazonium ion is this one. This is the electrophile. So where electrophile will go more, where will be the rate of electrophilic substitution more? Where electrophile can easily go. But electrophile always prefers which benzene ring, which phenyl ring, which aromatic ring, whose electron density is more. Have a look. Here it is the nitrogen which increases electron density. Here it is OH which increases the electron density. We know plus R value of NH2 is greater than plus R value of this. This is the plus R order. This is the plus R order. Now tell me, in case of aniline, can I say ring is having more electron density as compared to phenol? That's why this is having more electron density. So this prefers to go here as compared to here. So rate of this reaction will be simply more in aniline as compared to phenol. But if we are having phenoxide ion, we know its plus R order will be then like this. It is O minus, which is more, plus R, stronger plus R group as compared to NH2 as compared to OH. Because O minus will donate electrons more and it will increase electron density of this ring more. So it will prefer to go here, then here, then here. So if someone says you, where will be coupling, rate of coupling, what will be the rate of coupling? It will be like this. Rate of coupling order will be like this. Am I clear? Let me know in the chats quickly. Am I clear? Let me know quickly, my dear students. Am I clear? Okay, yes, sir. Clear, sir. That's great. That is great. Now, there are a few questions. Tell me the answer of these questions quickly. In the following reaction, the product A is a yellow dye, this is aniline, this is benzene diazonium salt. So it will result in the formation of para-amino azobenzene or 4-amino azobenzene. Now have a look. this is ortho, this is ortho. Now this is meta, this is ortho, this is para. So it is para, what we call amino azobenzene. Exactly, this is the right answer. After that, in the azo-coupling reaction, benzene diazonium ion acts as an electrophile. Very simple, very simple. Very simple reaction. Very simple reaction. After that, the coupling reaction of benzene diazonium chloride with phenol is an example of electrophilic substitution reaction. Remember forever, it is electrophilic substitution reaction. Remember this forever. Remember this forever. Remember this forever. After that, we will be having another question like this. Arrange the following compounds in decreasing order of reactivity towards coupling with benzene diazonium salt. Now this is phenol. This is phenoxide ion. That means here OH is attached to benzene ring. Now here it is O minus which is attached to benzene ring. Now after that, this is NO2 which is attached to benzene ring. Now this is NH2 which is attached to benzene ring. Now you have to find out order of resonance which will increase electron density of the ring more. There will be simply what we call, just give me a second once again. I will close this one. Okay, so let me know quickly. So it is O minus, then it is NH2, then it is OH, and finally this. Why this is electron withdrawing? It will withdraw electron density away from, I mean to say, that aromatic ring, and aromatic ring becomes electron deficient. So electrophilic substitution reaction will be obviously of a lesser rate in this. So first of all, it will be 2, after that it will be 4, after that it will be 1, after that it will be 3. So it is 2, 4, 1 and 3. Come on. After that, we have next question. Identify the final product. We have to find out this product. We have to find out the product. We have to find out the product. We have to find out this product. We have to find out this B product. Now, this is aromatic primary amine. On treatment with this, have a look. It will result in the formation of benzene diazonium salt. That means this one. So this is Ra. This is A. On treatment with phenol, this on treatment with phenol, this on treatment with phenol, in presence of basic medium, that means it is coupling reaction. So if it is coupling reaction with phenol, it results in the formation of para hydroxy azobenzene or 4-hydroxy azobenzene. Is there any option like that? Para hydroxy azobenzene. Yes, option number 3 is the right answer. Option number 3 is the right answer. So, let me know quickly in the chats. Am I clear till now? Let me know in the chats quickly. Now, as I have already told you in previous session that Unacademy is bringing you all India mock test series for all the aspirants of NEET 2026. And I have already told you that you must join this, and many of you have already joined, I hope so. But to the ones who have not joined yet, let me tell you, my dear students, go into the description, link is there, join as soon as possible, so that you can simply check where you stand, as this is the competition with the lakhs of students across India. And there are few, important points over here, that video solutions after every test will be given to you. I've already told you that. And top 50 get mentorship after every test. Join as soon as possible, because link is there, and all the very best to all of you. And this test will be always on Sundays, and that too from 2 to 5 p.m. I hope you enjoyed today's session. So this was all about our 20 concepts of organic chemistry, my dear lovely students. So a very big thank you for all of you. So thank you very much. Thank you very much to each and everyone there. I hope this is clear to you. This all session is clear to you, and you will join very as soon as possible. That means you will join this All India mock test series as soon as possible, my dear students. Now, this was all about today's session, but I want each and everyone that whenever I end this session, I need your support, I need your love, I need, comments that how much you, liked today's session. Do let me know in the comments afterwards. And second important thing which I want to say you is that our next session is there, and that session will be on 9th of this month at same time 3 p.m. So let's meet on 9th at 3 p.m. Till then, take care, God bless you, and love you all.